Okay, on number 28, you're asked to find the critical points and determine whether they are minimum, maximum, or neither. So to find the critical points, the first thing you'll need to do is take the first derivative, and we'll have to use the product rule here. So the derivative of x to the 2/3 is 2/3 x to the 2/3 minus 1, which is negative 1/3, times the second, which is 1 minus x, plus the derivative of the second, which is negative x, times the first, which is just x to the 2/3. Sorry, not negative x, negative 1. Okay, and let's clean this up a little bit. This is going to be 2 times 1 minus x over 3 on the cube root of x plus, or no, actually minus x to the 2/3, which is the cube root of x squared. Actually, I'll just write this as x to the 1/3. Okay, we need to get a common denominator, which is going to be 3x to the 1/3. So we're going to need to multiply this one by 3x to the 1/3 over 3x to the 1/3. And that's kind of cool because when you do that, you get 2 times 1 minus x, but this is going to be minus. When the bases are the same, you add the exponent. So x to the 2/3 times x to the 1/3 is just x, a whole x. So this is going to be minus 3x over 3x to the 1/3. And then you can simplify your numerator by distributing the 2 through here. So this is going to be 2 minus 2x minus 3x over 3x to the 1/3. And so then this is going to be 2 minus 5x over 3x to the 1/3. So your critical numbers occur where the derivative equals 0 or does not exist. So we definitely need to look at where the numerator equals 0. So at x equals 2/5, and then also where the denominator equals 0 is going to be where it's undefined, so obviously at x equals 0. So these two values are your critical numbers. X equals 2/5 and x equals 0 are your critical numbers. So to figure out what you have going on there, you're going to want to put them on a number line in order. So I'll put 0 here, and I'll put 2/5 here, and I'm going to consider the values of the derivative there. And so in order to save time, I'm just going to use my calculator as a tool. So I'll come in here, and I'll go to y equals, and I will type in my derivative, which was, and I'll just use the unsimplified one, 1 minus x times, or divided by, let's see, you have to put that in parentheses, so this is 3 x to the 1/3 power. And then, oh, that has to be in parentheses too. Okay, and then minus the x to the 2/3. Okay, and then I'm just going to go to my table and see what's going on here. Let me look back here. So let me just delete some of these guys. Okay, so a number less than 0 would be like -1. If I test -1, I get -2.33. A number between 0 and 2/5 would be like 1/5. And I get a positive number. And then for a number bigger than 2/5, maybe 1, I get a negative number. So that tells me I'm negative, then positive, and then negative again, which means I'm decreasing, increasing, and then increasing, decreasing. So I have a min at 0 and a max at x equals 2/5. Now to actually find the value, you need to plug it back into the original function. So like f at 0 is equal to 0 to the 2/3 times 1 minus 0, or just 0. So 0, 0 is your min. And then put 2/5 in to get your max. I'm running out of time, so you can just do f at 2/5 into the original function to get the maximum value there. Okay?